All right. So if you, all right, guys, thanks for joining, right? I just wanted to quickly recap what we are trying to achieve. It's not only about Magma, right? I wanted to really achieve in this 12 sessions, a complete end-to-end picture where, you know, any one of you who have completely attended all the sessions or anyone who is going to offline attend and go through the session, the outcome of that this continuous learning is you get a complete end-to-end picture, right? So then it will allow you to deep dive into the areas based on what you are working to excel. So that's the thought process. So we kind of started with understanding the wireline networks, wireless networks, and we learned standards and open source. Now we are starting to learn the adjacent technologies, right? So in next 4 or 5 sessions until we finish this, we will complete learning the adjacent technologies, and we will also try to learn the spectrum. So when we finish learning these theoretical stuff, which happens first 30 to 35 minutes, and in addition to that, this Magma open source is the second part of this particular session. After this 12 sessions, right? Even if you have missed some sessions, go back and go through this. You will see the value of this, right? A lot. Even in adjacent technologies, I wanted to even talk a little bit about decentralized, wireless and decentralized telco at a very high level. That will at least get you started what it is. Then how, why, we can always learn in the process, right? That's how you grow older, right? That's how you gain experience. But when you're starting point, what happens is in most of the companies, they train you on something and they'll put you on that, and they will make you to do only that, right? So it's not something that's going to work in this period of technological evolution that we are working on. It's never going to help, and a lot of people don't understand. Even today, you see a lot of educational institutes have programs like programming language, this, that, and a lot of people for certification go and join. But one thing you don't realize is that nowadays things have so much changed that certification, accreditation is not a big thing, right? What is big thing is what you can deliver is the big thing. I mean, the advent of open source, advent of a lot of open things that's happening now has actually enabled people to innovate, and even guys like 10 years, 15 years, 20 years are billionaires nowadays, right? So it's a different world that we live in, and only you can do that when you understand the big picture. If you don't, and it's not only what you're learning here, right? Even when you do day-to-day job or anything that you do, always focus on understanding a big picture. What is it as a whole means to the world and to the people and to me? And once you have that complete understanding, then you would be able to make a right decision, take the right choices to make your life better, right? So spend time as a continuous learner to understand the big picture, whichever the area that you're choosing, right? So this is very, very important. And that's what we wanted to really achieve. I was just thinking through, we just presented 15 minutes, 20 minutes in every sessions. When I went and looked back, the number of slides that we have gone through and we have learned is almost like 80 plus, right? And still we have like 5 more sessions to go to learn multiple other things. So it's very powerful from that point of view, right? If you take a step back and look at it. Okay. The other thing that I wanted to quickly, from the logistics point of view, share is these 5 links. Let me put it in the chat. Right. So if you need anything, you can just contact. If you want to support this nonprofit initiative, you can support. We recommend you to register it in the Eventbrite. But if you're lazy, please copy this and create a calendar record, and please do join the sessions, right? So with that, let's go back to today's session learning. So if you look at where we are right now from the point of view of agenda is we are in the process of learning adjacent technologies. So last session I kind of introduced, started on that topic, and I introduced the cloud and SDN, right? So that's what we introduced. So I'll just do a quick recap. One of the things that I wanted to do is Parthiban, right? I'll try to take a little bit more time. I know that whatever you told me probably will take 2 sessions, I think, for today. Okay. You may not be able to complete everything. Probably you need to split half to today and half to the next week session, if you're okay with it.
Yes, Kadir, we can do it even in that way. As we have half of the content even in our session is of recap of the Magma's content. We can go over the different types of registration in this call, and in the next call we can talk detail about how these different algorithms are used in different registrations and how actually a demo is being done. We can move the demo and the deep dive of information element level discussion to the next session.
Okay, thank you, Patim. Right. So I just wanted to see if we can cover this cloud and NFV part, SDN part, because it's one single concept that at a high level, if you get a grasp, it's very easy to jump in, right? And I'm sure some of the DevOps team members are also here, which will help them a lot. Okay, let's get started. A quick recap. Why do we need to really learn adjacent technologies? Because see, what happens is, it's a different levels, right? So when you do a programming language, you only learn the programming language, then you go to another programming language. But what's more important is when you're learning a programming language, what you need to learn is the concepts. What is polymorphism, right? What is classes, objects? What is inheritance? How do I build a design and architecture that I'm going to build a product using all these concepts? That's what is a big picture that you need to learn when you're learning programming languages, not syntax and APIs of different actual programming language, right? Because that you will learn anyways when you're implementing the project, and maybe if you once you understand the concept, even in a day or two, browsing through the programming language book, you know where things are, and you can always keep your book open and do coding. But when you understand this whole big picture of different concepts, how architecture design, good coding skills, how do I actually write a code that is optimized? It's not about writing one line very complex, right? It's like writing 5 lines, taking less CPU time to make your program very powerful. That's the big picture I'm talking about, right? Once you are good in that, then you can do programming in any languages. Okay. Nowadays it's so easy. Even function as a service is going to allow you to just call the function. But only that's the thing, right? It's the same thing here as well. When you're learning connectivity or 4G or 5G technology, what is important for you to understand is also how this is as a concept, right, connected to all of the technologies and how different technologies all come together to make this happen. Okay, this is what is very critical, and that's how you should start thinking. That's how your brain should work, right? So when you start processing your brain in that way, when you're able to connect multiple dots, then you would feel like, the Buddha gets to an enlightenment, right? You will feel like you get to that enlightenment, then everything will look easy for you, not difficult. Okay. Oh, this one. Oh, okay. So this is what it is. We'll do is now let me assign this to someone else or open the book and do. I mean, that big picture is going to make and help you to see everything else small and easy. Otherwise, you will get more. It's so difficult. Because why? Because you don't know the big picture. You don't see the big picture, right? So it becomes very difficult and things like that. So that is why it's very important that you build an intrapreneur and entrepreneur skills, right? Not from the business point of view, at least from the big picture continuous learning point of view. So if you take that as an example, even though we are learning 5G, but all other different technologies that are related to this particular technology to offer different solutions, products, platforms, whatever that you're building, right? And again, a big picture, the whole world is building products that brings physical, digital, and human aspects together to solve some customer challenges. That is what it is, right? Every single product in this world, it does that. From the pen to big aeroplane, any product in this world, that's what it does. You might use multiple tools and frameworks, technologies to do that, but in a big picture, that's what it does. So one of the most important concept that I wanted to cover, and I kind of covered it in the previous session as well. This is kind of a recap. I explained what is cloud, right? You can always go back and look up the previous session. The key message here is that the cloud was initially, brought into this world, mostly by the web and enterprise IT guys, right? During the web 1.0 and 2.0 phase. Okay. And then the cloud, there are different types of clouds were defined. public, hybrid, private, community, and also there are multiple other innovative clouds names also has been given. And the most important thing is what cloud did was fundamentally, instead of me investing hardwares, power, space, and everything, I let someone else to invest that, and I just rent it. It's like a house rental, right? When you're doing a building an apartment, right? Either you can build everything and you live yourself, and then you can build and give it to others to do it, right? You have an option to build yourself, or you just buy it from someone who is building it, right? It's the same concept. That's how the cloud evolved, right? And then various number of services evolved, and we talked about it. Here I showed the example of up to software as a service. Then we went into this link and we looked at it. There are so many as a service are available today. If you take Microsoft, Microsoft is a platform provider, right? And Google is a platform provider. They provide you the platform to build products, solutions, services on top of them, so that you can use their cloud, so they can make their money by providing the cloud. Now, when they're providing the cloud, they started with providing just the servers, and then eventually tools, frameworks, everything they brought in. And even like I mentioned, they went up to function as a service, where all you have to do is write a main program, call the functions, everything they take care of. It has got positives, and also it has got negatives. But depending upon the customer use cases that you're trying to solve, it will help you which way that you wanted to choose. Okay. Then the second quick recap is we talked about SDN. SDN, again, it was mostly on the enterprise side they started, because they were having expensive routers, switches. How can I reduce the cost and still control everything by software rather than being dependent on the hardware to do the transport, right? That's how this thought process in enterprise started, because in enterprise you have all these data centers, routers, and switches. And how do I simplify that, right? So that's where the software-defined networking came into the picture. So from the definition point of view, what does it actually mean is, if you take a router, there's so many protocols, right, that are available, that discovers one router, next router, that allows a message from one computer to go to another distant computer that message is supposed to go. So that's what the router, switches, and everything does. And there are so many control protocols that are available. Anyone can share any protocols, the old protocols in the routers?
Like BGP, OSPF.
Exactly, right? All those protocols, right? Those are all the protocols that allows you to make sure that everything is in sync, and then you transport the data. So they want to kind of simplify that. So they separated the control. One definition you wanted to remember, what is SDN? Separation of control plane and data plane in level 3. That's what it is. Level 3 separation of control plane and data plane, not level 4, right? Level 4 is your attach and then your GDP tunnel, right? But this is level 3. Level 1 to level 3. Separation of all the signaling protocols, control plane protocols in level 1 to level 3, and the data plane protocol separation is called as an SDN. So what it allowed you to do is, you are able to put an SDN controller and control multiple small boxes to route the data, and all the configuration goes from the SDN controller to all these boxes through XMPP, OpenFlow. I just gave some example. So you're controlling software voice, right? Software-defined networking. Okay, you're controlling everything through software, sitting as a controller, which is an SDN controller, and telling all the hardware, okay, when the packet comes like this, route it from this IP, which is this box, to another IP, this is this box. So that is what the SDN controller is all about, okay? Which kind of eliminated all the complex control, level 1 to level 3 protocols, complex equipments, expensive equipments. It's allowed operators to deploy cheaper equipments, which eventually, enterprises to deploy cheaper equipments, which eventually, increase their return on investment. So if you think of practically, I kind of hand-drawn this just to explain what I think in my mind, right, rather than picking some other slides. So if you actually think about it, you have different access networks, and then you have a packet and optical transport. On top of that, you have our 4G, 5G, and all other networks, and then on top of that, application that sits right at a very high level. So you have an access network, transport network, application that sits here, and then application network. Actual application sits here, and then application network is here, right? 4G, 5G, and whatnot. Okay. So the SDN basically, is a software piece that sits and controls all these small boxes to move the data from one origination to the destination. So that's what the SDN does. So if cloud plus SDN means, see, if you think about it as an evolution, right? So cloud was basically done by the web guys. It was sitting in Amazon, Google, whatever. In the initial times, what we were doing was mostly we were deploying all the applications like web pages, all small applications that you were doing, right? Now complex application you started deploying, but not anything like in the cloud. It was you never deployed, for example, in the past, olden days, MME, you never deployed BSEs, you never deployed anything here, right? Normally, only the simple applications were deployed. Most of the network functions and other things were all here. And then you have all these transport things that were all here. So that's the kind of a clarity I want to give you, right? This understanding where the cloud was and where the actual SDN was, right? And at that time, there was no NFV, right? NFV came after. So here, still people were using mostly the hardware boxes, okay? Like hardware MME, hardware BSEs, hardware-based, SBCs. That's what was used at this level at that point of time. So now moving on, then became NFV, right? These three concepts are very important, and understanding a big picture, the separation between these three is also very important. Okay, so the NFV is the network function virtualization. So this telecom guys, they looked at cloud guys are making a lot of money and they're doing a lot of things and in a more efficient way, agile way. Then the telco they wanted to do in the similar way for their telco stuff, right? So that is this stuff here, wireless and fixed PNS, right? So they came up with an equivalent cloud concept called network function virtualization. And all they did was all the hardware stuff that was used here, they tried to softwareize it. Okay, so most of the layer 4 to 7 devices is one way to remember. Softwareizing that is NFV. And in all the three cases, whether you take cloud, SDN, or NFV, okay, it's all the functionalities like virtualization, multi-tenant, elasticity, automation, innovation, everything is applicable in all the three. The concept of all is the same in all the three. Okay, so the NFV is nothing but telco's name for the cloud for layer 4 to layer 7 devices, and who originated the service providers, right? The SDN was enterprise IT, and then the cloud was web guys, right? So this one is done by the service provider, and you can use the NFV with SDN, without SDN, obvious, right? Because here you use NFV, here you use the SDN. So I don't want to use SDN, use the traditional routers and switches and just use NFV here, or I can use NFV here and I can use the SDN here both together, and I can use all the three together. Okay, and initially it was OpenStack, virtual machines, VNFs, and things like that. Nowadays it's containers, Kubernetes. So the difference between the containers and Kubernetes, the Kubernetes containers and virtual machine, right? Virtual machine is like a virtual computer, and which has like different OS and stuff like that. Container shares the same OS, right? And then on top of that, you have multiple placeholders where you can deploy your applications. Okay, so that's the connection between the cloud, SDN, and NFV, right? So NFV is where here. So this clarity is very important to understand. You might be reading all these things, but take it as an lesson. Why I explained before starting this presentation, to understand the big picture, to explaining this, there is a connection, right? So whenever you start, your brain starts to work. See, my goal here is to make your brain work the way that it is supposed to be, so you can be very successful, right? That's my continuous learning that I wanted to give it to you guys, right? So when you are learning cloud, SDN, NFV, first thing should come into your picture is, rather than going and reading all these documents, understanding what are all the functionalities available in AWS, Google, NFV, what stuff are available, is understand where in this whole thing all these things are placed, how all these things are come together. Once you understand that, then everything else becomes easy. Why? Because see, sometimes you can put the network functions in the cloud. Before it used to be only the applications. Now you can put network functions also into the cloud. Nowadays you see Amazon, Microsoft, they are putting the network in the public cloud. Nowadays we put applications that used to run in the public cloud into this private cloud. And you can have mix of these two things. And you can put SDN into this place, and then you can control the transport. Even you can put SDN into this place, and you can control the transport. You can do it in any ways, mix and match. It's like you have all the ingredients. Once you know all the ingredients that you have that knowledge, then you can mix and match to cook different dishes. In this case, it's use cases. Right? So that's the key message that I wanted to give. Okay. So now moving on, I try to draw something for you guys to give a little bit more clarity into what I meant by mixing and matching, right? So if you look at legacy, so you have the applications that's running on VM. Nowadays, you can, it can run on the Kubernetes, okay? But nevertheless, from the concept point of view, let's say these applications are running in VM. Then you have a transport, an expensive router where the control traffic and user plane, control plane traffic and user plane traffic is sent from origination to the destination, right? And these applications, basically through whatever is running on the data center and the servers, they connect to the network port, NIC cards, and then it comes out and it goes through this and then it comes back here, right? This is what happens, theoretically speaking. Whether this router is a virtual or physical doesn't matter, right? But that's what happens in the legacy side from the concept point of view, right? Now, if you have without NFV, whatever I explained, right? So then what you do is you have an SDN controller, and then there are small bare metal switches, which is like $50, $100, rather than buying a router, which is $5,000, $10,000. And over that time, it was like $50,000, $100,000, right? So what you do is you just put an SDN controller, as an example, Open Daylight, and you just buy the bare metal switches, and then you route the traffic from incoming to the outgoing through the bare metal switches, and the control plane, what these bare metal stretches from here, when the incoming traffic comes, how it should route, you basically educate that or instruct the bare metal from the SDN controller. So this is how they splitted the traditional router control plane and user plane into SDN controller, which does the control plane, and the bare metal, which forwards the user plane. This is what the SDN is all about, software-defined networking. Okay? This picture probably would have given you more clarity. Now let's go with NFV, right? So it's the same thing. Now, what happens is in the previous slide, you had just web pages and stuff like that here, right? Some enterprise applications and things like that, right? Now, here, what you are trying to do is you are basically trying to put in this application the network functions, softwareizing the network functions, layer 4 to 7, right? Now, the another piece that I wanted to kind of share you here is you can put SDN controller anywhere. You remember mix and match, right? You can put SDN controller itself as a VM or a container, right? And then you can instruct these, or you can put an SDN controller inside the software part of the SDN controller. You can build it inside MME or inside, SMF, and then the VM when they are routing, they directly go to the SDN, and then you do it, right? And then you have a master controller which manages all these things. So there's number of ways you can mix and match. Innovation is your limitation, right? But you have to understand the big concept. You can put SDN everywhere, you can put network functions everywhere, but end of the day, what you are trying to achieve is you're softwareizing it. You are separating the, simplification means you are disaggregating it, right? When you disaggregate it, you simplify it, you reduce the cost, but that comes with another additional cost of maintenance, right? Then you got to do automation and orchestration. So now without doing automation and orchestration, lifecycle management, it's very difficult to manage the disaggregated network. Now, how do I do that? You need an automation technologies, right? Process automations, you need RPA. And the intelligent automation, you need AI, analytics, data engineering. So that is how all these different technologies are connected. And everything is connected together, right? This is another diagram where I wanted to kind of share it with you. I have not explained you what is an NFV architecture, but I will explain. But the most important thing here is that you see here 1, 2, 3, 4, 5. For now, you don't know these architecture. I'll explain in the next slide. Just remember, you can put SDN controller anywhere. You can put it in OSS, BSS. You can put it in as a component within the MME VNF that you define, right? And you can put it inside this virtualization layer here. You can even put it in the Vim OpenStack. You can put an SDN controller there, right? You can even put it as a separate box, physical box, and you can control all the bare metal switch. But the point is two things. The first point is you understand the clear difference between cloud, SDN, and NFV. And the second point is it is up to you to architect and design based on the customer requirement. Now I'll go back to the example that I said, programming language, right? Understanding all these concepts, knowing how to design, knowing coding standards, what you should do to optimally utilize the CPU and memory is more important than you learning if, else, API name, input parameter, output parameter. Because if you don't understand that part, whatever code you will write, it will not be optimally used. So you guys, if you are a developer or a tester or an operation expert, because everybody has to be a developer nowadays, there's no testing only guy. It's all gone 5 years, 3 years ago, right? So you have to go back and understand this concept. Go and look for what is coding standards. How do I design? How do I architect? What is optimal architecture? What is optimal design? When I write a code, when do I use if? When do I use case? And how the instruction set, how the memory and the CPU is going to be allocated on using all these different things? Is that applicable for my use case? If you are master in that, you will be the super coder. You will build product, so amazing product, high performance product, like anybody else, nobody else. This is where the difference is, right? So I had worked in my past. I'll give you a practical example, right? There was a project that we did without getting into too much of details, just one blade with 8 cores, even 1.8 core, 1.8 gigahertz, 8 cores in one blade with few hardware acceleration card, right? We were able to achieve close to 500,000 concurrent RTP, SRTP streams. Now, there are vendors who were able to do only with the similar resources, only 5,000 RTPs, SRTP streams. Now, what's the difference? They are also coders, they are also coders. Understanding the big picture, knowing what is the right thing to do. That's what will make you a very good coder, right? A very good technologist, very good, you'll have a very good future. Let me put it that way. So that's what I wanted to really connect. When I started the session, that's what I gave those examples to come back and connect. So you will never forget the difference between cloud, SDN, and NFV from the concept point of view, and you can mix and match depending upon the customer use cases, and you can take it forward. As a summary, right? Cloud plus SDN plus NFV. Like I said, cloud is applications. NFV, what is the result of NFV and SDN? Reduced CapEx, OpEx, but only main differences between layer 4 and above for NFV, 1 to 3 for SDN. So that's the kind of summary I wanted to give you guys to understand between the differences between cloud, SDN, and NFV. In our next session in 2 weeks, what I plan to do is go a little bit deep dive into NFV to kind of explain you guys what is the architecture of NFV, right? And how is this all different things that come together, okay? And then descriptor and resources. So I'll tell you what do I mean by this, right? Nowadays you have heat template. There are so many templates. If I tell Tapas or anyone DevOps guys here, they will talk about. But what is the concept of those templates? If I go and ask, there are DevOps guys who have done so many things. But if I ask them what's the difference between the catalog and instances, what's the difference between descriptor and resources, maybe they may not know. Right? But anyway, so that's the thought process, right? So the next session, we will deep dive into the NFV, and then we try to close that with the edge computing, right? That's what we do. And then we will start looking at some additional technologies at a very high level, what it is, and why 5G is relevant for those technologies. And then we kind of complete this technology session. And the last 2 sessions, we will focus on spectrum. Okay, or maybe 1 session we will focus on spectrum, right? So that's the thought process. So with that, I will pause here for any questions and then hand over the session to Parthiban and Neelama. Guys, was it useful? Were you able to understand? It's a simple concept. but it's very powerful.
Yes, Kadir. I think that was the
Yeah.
Okay, perfect. Over to you, Parthiban. You have next 20 minutes.
Yeah. Thank you, Kadir. Along with me, I have Nilima, who is going to share screen and present. So Nilima is a senior validation engineer from Wave Labs. Nilima, can you put your screen share, please? Yeah.
Yes, sir. Hello, everyone. Let me share my screen.
I also encourage every one of you to prepare something and present.
You can.
Right? It's the confidence as well for you guys. So far, you all doing a great job. Okay, go ahead, Nilima.
That's awesome. Yeah, thanks, Nilima. Yeah, I think you can go ahead and present till the point, recap all the older session details and discuss up to the different registration types today. Then maybe we will take the demo and deep dive off into packet captured PCAPs and stuffs, demos and everything in the follow-up session.
Sure. Yeah. Hello, everyone. Today we are going to talk about different registration types that we are supporting in Magma. I'm sorry if I'm not audible. Please let me know so I'll increase my volume.
Yeah, you're good to go, please.
So, the main content of the session will be like a recap of Magma Core and orchestrator basic architecture at high level, and different procedures and hardware requirements for deploying access gateway, and different registration types, and basic PCAPs, and the short demo video on how SUSI registration works. This is the basic architecture of Magma. And if you see here, it's an open source and converged core. It's converged core because it supports both the 4G and 5G. And it is very flexible architecture for extending the services. And it is like compliant to 3GPP. It's a cloud native and API centric and distributed architecture. The major components of Magma Access Gateway consists of Magma architecture consists of Magma Access Gateway, Orchestrator, and Federation Gateway. And Magma is the main service which manages all the services in the Magma Access Gateway. And the other components are the OVS control proxy, InnoDB, and MME, which handles the MF services, Mobility D, then Pipeline D for UPF functionality, Policy DB for policy related functionality, PCF functionality, Session D for which handles the SMF, and subscriber DB for UDM functionality. And coming to Magma Orchestrated, it is a centralized control unit. It is used to manage different access gateways in various networks. And there are two major interfaces in Orchestrator. They're like northbound and southbound interfaces. Northbound is for primary, like a vendor agnostic API related interface, and southbound is for configurations and reports, like collecting the metrics and all other reports from the gateways. The main basic requirements for an VM are hardware to deploy the access gateway, or we require in 4G core CPU, 4-core CPU support, and RAM should be 8 GB, and hard disk requirement will be 60 GB, and we should basically require two interfaces, that is ETH0 and ETH1. Always our interface will be picked on ETH1, and the Linux based deployment, it requires Ubuntu server of 20.4 version. And here we are supporting basically SUPI, SUSI, and Booty based registrations. SUPI is nothing but a SUSI based registration without any algorithm. It is a null scheme registration process. Whereas SUSI, it is a concealed process of registration where we use different algorithms like Profile A and Profile B. And further going, we'll see PDO establishment and release procedures, deregistration, and traffic support. Coming to the registration types, if you see SUPI is nothing but an permanent identifier, subscriber's permanent identifier. It is an variable length, like 15 or 16 digit length, and like basically it consists of MCC, like mobile country code, then network code, and then MSIN value. MNC is in variable length. It can be a 2-digit value or a 3-digit value. If we see here, this is an mobile identity I which carries the type of registration and the other subscriber related information that consists of mobile. What is the type of format? SUPI format. It is like Magma supports it as an INC. Then type of identity, it is a SUSI based identity, and MCC and MNC values followed by a protection scheme. For SUPI based registration, it will be null scheme, and then MSIN. This is subscriber identity value, which is a 10-digit value, and in case of SUPI, it is like exposure to the network. Coming to GUTI, it is a temporary identifier which is assigned to an user during the registration process. This is assigned by AMF, and it is consisting of MCC MNC value, then the AMF region ID, set ID, and one more is like AMF pointer ID, and then 5G TIMC. Here 5G TIMC is a temporary mobile subscriber identity value. Like it is for identifying a user within an AMF region. So it cannot be used to identify the user beyond that region. And it is an AMF can reassign this GUTI parameter at any point. Am I clear till this point?
Yes, Nilima. Yeah, you're good.
We'll go into the subscription concealed identifier. This is nothing but we are hiding the identity of user from the network, where the MSIN will be concealed. And the major parameters here are SUSI type, home network identifier, route indication, protection scheme, home network public key, and the scheme output. Just to preserve the user's identity to the network, in the network we use concealed identity, and for deconcealing the MSIN value, we are using ECIS based protection deconcealing algorithm to find out who is the exact user, like what is the MSIN hidden in that scheme output. And to generate the key pair, the key parameters are like a home network public key identifier and the scheme. What is a scheme? Either it is a profile A or profile B. As of now, Magma supports profile A and profile B. And for profile A, we are using X25519 as the algorithm. It is an Diffie-Hellman algorithm. And for more details, we can go into this link, which explains the detail about this algorithm, how it works. And coming to profile B, we use ECDH spec algorithm, and this is also an Diffie-Hellman algorithm, but this is an elliptic curve algorithm which gives more protection. And this is a flow diagram which explains like how at the user end this scheme output is generated, and this scheme output is consisting of ciphertext, ephemeral public key, and MAC, which is used at the access gateway side to deconceal the MC. And yeah, this is about
yeah. I think we can go ahead with the demo, short demo, Nilima, because you have run through much faster. Let me ask the team here. Anyone has any questions or anyone has any more clarifications? I know Nilima was a little faster.
Oh, I think Nilima did a wonderful job, Parthiban. Right?
Yes.
We all start, and you covered it really, really well. You should be very proud of yourself, Nilima.
Yeah.
Good job. Yeah, we can move forward with the demo. If any questions there, we'll address and then we can move forward.
Okay. So I'll start the demo video if anyone not having any queries till now.
Yeah, go ahead, Nilima.
So this is like our NMS UI page where we are adding the subscriber information. This is the equipment information. Like in the equipment, we'll have the access gateway that is registered in the network. and it describes about different parameters of and this is the subscriber information, like what are the subscribers that got registered in this particular access gateway. And this is the detailed information about the subscriber configurations, like what are the APNs that got registered, what are the other key values and OPC values that are binded to the subscriber. And this, just to make sure that the subscriber information is properly registered, like we can see that in the access gateway as well. This is my Magma access gateway, where by using this get INC information, it will display all the subscription for a particular INC parameter. So what are the APNs and everything that is seen in the NMS page. And now these are the for SUSI registration, we should have the public and private keys that are already assigned to a user in the access gateway DB as well. This is a subscriber DB consisting of this profile A and profile B keys. For protection scheme 0, it indicates it is for profile A. These are the private and public keys. And for protection scheme 1, it indicates for profile B, and these are the private and public keys. So, and in this demo, I'm using bot as my tool to trigger the SUSI-based registration. Here at the UE side also, I have to configure these keys, where this will generate an ephemeral scheme output consisting of ephemeral public keys and ciphertext and MAC. So, and this is my test case, which will trigger the entire procedures like registration, some procedures of registration like authentication, security mode, and then PDU session, and everything followed by that. So yeah, my test case is getting executed here. Maybe I can quickly pass through. Yeah, here I'm going through the PCAP. This is my first registration request, where I'm just showing like how the registration request goes. It is an SUSI-based registration with the protection scheme as A, and the scheme output is consisting of ephemeral public key, ciphertext, and MAC. At AMF side, we can see that INC deconcealing is happening. Here, using these parameters, INC deconcealing is happening, and subscriber DB gives the INC that is deconcealed, and from there, the rest of the procedures will be triggered parallelly, like the authentication and the security mode and registration accept will be done. After registration accept, MF will assign the GUTI parameter, that is TIMC. And for re-registration, and this GUTI parameter will be stored at the UE, and he will use it for the re-registration during the GUTI-based registration. You see here, the second registration is going with the GUTI-based registration, where we have to fill all the MF, set ID, region ID, MCC, MNC, and then the TIMC, that is temporary mobile subscription identifier. And from that INC value, AMF has to find out who is the respective INC. For that, he will again query for the identity, that is like identity request, and the response is going on. And then followed by PDU establishment. Here we'll have all the session types and then the DNN or APN that is subscribed for this particular user, everything. Once after getting the setup response, that means with this our PDU session is established and user can start browsing internet in that using the PDU session. And once we want to release the session from UE, we can trigger in a PDU release request. With the release response, the entire session will get release complete. The entire session will get cleaned up, and by doing a deregistration, entire context of that particular user will be cleaned from the AMF. This is the entire call flow with the SUSI-based registration. And this is with the profiling. Similarly, I'm having for profile B as well in this demo. The basic difference between profile A and profile B is nothing but the algorithms we used here. Other than that, the scheme output consisting of ciphertext, MAC, and ephemeral public key, everything is common. And in Magma, basically ciphertext is a variable length, and we are supporting variable length of ciphertext as per in Magma. So with profile B, my test case is going on.
Maybe Nilima, it will be good if you have a PCAP capture. We could open up and show on
Yes.
the live PCAPs, whatever you have.
Yes, sir. And then I'll stop.
Yeah, it's going to be the same 5G call again. So
Yes,
it'll
sir.
be great if we could go to, maybe you can increase the font and yes, this will be more interesting to go into deep of at information element level, IE level, and we can look
Yes,
at
sir.
all the IEs what
Yeah.
are being received in profile A, profile B.
Okay, sir. Yeah, this is with profile B, as we had seen in profile A how it's going in the video. I'll demonstrate with profile B here. Once the connection got established, you will send in registration request, and here we are having an ASPDO parameter which is consisting of mobile identity. And this mobile identity IE, the user is going to specify what is a SUPI format, that is MC, and then type of identity, either it is SUSI or GOTI. And then if it is a SUSI based identification, we have to we'll have that MCC, MNCs, and the protection scheme identifier, which is profile B here, and home network public key identifier. The key that is used to generate this, and the same key has to be used to deconceal the MC as well. And the scheme output. The scheme output is divided into three parts. Those are ephemeral public key and ciphertext and MAC. So these are different components of that. Then we are having 5GMM capabilities, user security capabilities, and everything, network capabilities. All details in this registration request. Then once the deconcealing is done and MF knows who is the MC, he will check out from the UDM or subscriber DB whether this particular user is registered. If he get a response from subscriber DB, he will start the authentication procedure and he will authorize the user. And then he will start a security mode security procedures. And once the security mode complete is done, that means he's accepting this registration, and he will send in registration accept towards UE, and then context setup request towards the GNB. And once the GNB is responding with a response message, both the peers are having a UE context saved. And once a complete message is received from UE, the entire registration procedure will be done. And then for re-registration, I'm using a GOTI parameter here, where my identity type will be GOTI, which is consisting of MCC, MNC, and then AMF region ID, set ID, and pointer, and then temporary identifier of the subscriber, TIMC. If we see here, the TIMC assigned during the registration accept is used for the re-registration. So from since MF is not having the MSIN details here, he will go for an identity procedure to identify who is the exact MSIN. So here we are having identity request and response. Once he got the exact identity information of the subscriber, he'll go for regular procedures like authentication, security mode, and then once the entire registration is complete, he will go for PDO establishment. Then for cleaning up, he will go for PDO release and deregistration. But the release command, the entire context will be deleted from MF side.
This is really great. Yeah.
Here as an like this is a simple screenshot of the PCAP, whatever I had demonstrated over there, and as part of as an add-on feature, like we are having our Swagger API from where we can configure the. I mean, we can add this public and private keys into MF subscriber DB. So these are like all about the Swagger API configurations. I'm sorry. Yeah. So whatever we are passing from by using put command of Swagger API, those subscriber, it will get stored in the subscriber DB, and by listing that we can get what are the keys stored in the subscriber DB, and these are the keys used for deconcealing the MC.
So team, this is going to be available in the upcoming 1.8 release of Magma. Somebody who are very keen and interested can even try it out from the latest master in the Magma repo. So these are something add-ons. So that's where this is not been shown in the demo, but we have covered here for the team to try it out. If somebody is so interested to try, how do I configure my private key, public key for trying different registration types when I want to do the 5G call, then you can use the Swagger API, which is available from the latest Magma master orchestrator.
Yeah. And as a conclusion, we can see that like Magma is an open source code, and it is a converged core which supports multiple platforms, and it is like a API centric, cloud native, and distributed solution.
Awesome.
Thanks
a lot, Nilima.
Thank you, Neelam. You did a wonderful job. You should be very proud of yourself. Very, very happy. Good job. Good job. Team, I think we are almost close to our time, right? We always respect the time. Make sure that you attend rest of the sessions to understand the concept as well as some of the areas. But I also wanted to highlight one single point as a takeaway today is, please, even though you work in different customer projects, different domains, you are joining this call because you wanted to learn connectivity, 5G and 6G in future and all those different technologies that comes together, right? So take your time and create an interest as a continuous learning interest, every one of you, to learn 5G and eventually 6G, because that will make a lot of difference personally for you and the company that you work for, because it's like this, right? When you're constructing your house, the foundation is so very important, and for different people, different things is a foundation. But one of the greater foundation that you can build upon is connectivity, because that's the foundation that connects everything, whatever you do above and beyond, right? So, and also you will have a great future, right? When you have a good connectivity expertise. And the barriers, there's no barriers, right? So please see whether you are a DevOps expert, try to understand connectivity and how DevOps is connected to that. If you are a coder, do the same thing. If you are a tester, do the same thing, right? If you are working in AI, try to understand how AI can actually help the connectivity better than today. AR, VR, how AR and VR can help connectivity better than today. How AR, VR and AI-based applications can run on the connectivity that will give the result that is desired and expected, right? So think from all these perspectives and see how you can develop your skills, right? That way it's going to help you. As an example, if Ranjan and and few others working on IoT, then how IoT is related to connectivity. And for my application, how am I going to do it? Digital twin, how is it applicable? Right? So think from all these perspectives, and I'm confident that you will be very successful as a continuous learner. So with that, let's close the call. If there is no further questions, you guys have a wonderful weekend, and those are in Asia and Europe time frame, have a wonderful evening. Take care, guys. See you all in 2 weeks.
Thank you, Kader. Thank you all.
Thank you, everyone. Neelama, good job again. Excellent work.
Thank you,
Bye.
sir. Thank you, everyone.
Thank you, Kader. Thank you all.
Thank you all.
Thanks, everyone.